Hello, lovies. These are the solutions for Lesson 84. Check for understanding Lesson 84. Lesson 84 is our introduction to complex sampling methods. So we started with the two bad ways to sample. We don't want to do convenience sampling, and we don't want to do voluntary response sampling, because those samples often or those methods, I should say, often lead to samples that do not represent the population. So then we moved into the good sampling methods, and we talked about three basic sampling methods. So that was HAT method, using technology, and random digits table. Now remember, those are all simple random samples, so they'll give you a good sample, maybe not the best sample. So then, for this lesson, we move into the complex sampling methods. And notice right up here, these are not SRSs. They're more complex. They have a statistical advantage, meaning they will give you, in most cases, a better sample than an SRS. So our first one was systematic. The keyword that we're looking for is every nth person. So whenever they're describing a systematic sample, you're taking every 5th person, every 8th person, every 50th person. How you determine where you start and what nth you take, you usually do your population size divided by your sample size. Then whatever number that gives you, you randomly select between 1 and that number, and then you take every nth of that number afterwards. So that sounds very abstract, so let me just give you a concrete example. So here in this very small sample, you had 10 people. If you do n, capital N divided by little n, you get 2. So you want to randomly generate a number 1 or 2. The idea there is you want to randomly generate it using an SRS. So I could quickly go math, probability, 8, 1, 2, enter, and just like this example does, I'm starting with person 2. So person 2 is colored in, and then I take every second person after that, which just looks like every other. So I start with 2, 1, 2, she's colored in, 1, 2, he's colored in, 1, 2, she's colored in. So that's a systematic sample. 2 is, or the second one we talked about, is stratified. The key here with a stratified sample is you divide your population into groups that look the same. So we're talking about all 8th graders, all 9th graders, all 10th graders. When you look at one strata at a time, it does not look like the population. So if I stratify by grade level, and one of my stratas is 9th grade, that strata does not represent the population because there's 9, 10, 11, 12th graders. In order to make a stratified sample look like your population, you must combine. So you take the same amount from each strata, combine, and you have a good sample that represents the population because you can control how many people you take from each strata. If you did this as an SRS, you run the risk of getting a majority of one grade level. That's bad. We want equal representation. Next up was a cluster sample. Cluster sample is still better than an SRS. So a cluster sample is still better than an SRS. However, it's maybe not quite as great as a stratified sample. The reason that we would take a cluster sample instead, though, is because it's convenient, it's more convenient, and it takes less time. So it kind of sounds like a convenient sample, but it's not. There's a lot of intention behind the clusters that you choose, but compared to a stratified sample, this is much faster and easier to take. So then we moved on to actually looking at what we would do, the steps we would take to gather these samples. So we walked through step by step how you would take an SRS, a systematic sample, a stratified, and a cluster from this auditorium situation. And as I was getting toward the end, I realized that this probably would have been much more beneficial to you if I would have split these out and had you actually carry out the sample. So just like we did in class for choosing students from a random digit table and using technology, and even me drawing the names for the candy, I should have given you your own auditorium for each sample and had you actually carry out the sample. So that's what you're going to do. If you're a B-Day, that's what you're going to do when I see you next time in class. We're going to totally make sure, or we're going to make sure that you totally understand these sampling methods. I will give you this auditorium and you will carry out these sampling methods for each situation, and you will turn it in with your overview. So make sure that as we go through this check for understanding, you come back prepared, or you email me with questions so that I can clear up any confusion so that you can be successful at that task that I'm going to give you. So the one thing that I want to mention that I didn't cover in the video is I went through and found an SRS. I didn't do this on our example, so I did not do this here in the video. But I went back and did it afterward because I wanted to show you that with an SRS, there can be an issue. And that issue is if you take a true SRS, meaning every student has the same chance of being chosen. You do not group by grade level, you do not cluster, you just put all 60 names in a hat and draw out 20. You run the risk of getting a majority of one grade. So I actually did a simple random sample using my calculator, and I ended up getting 5 freshmen, 7 sophomores, 3 juniors, and 5 seniors. This is not horrible, but look here, like 7 sophomores and 3 juniors, probably not the best sample, and by probably not, I mean not the best sample, especially if I'm asking a question that affects sophomores or juniors. So we want to keep in mind that an SRS is a good sample, but in this case, stratifying would be better because I can ensure that I get 5 from each grade level, whereas here I can't ensure that. That is the biggest distinction and thing you need to know when comparing an SRS to stratified. They're both good methods. This one has a statistical advantage because it gives you a better sample. Now these two compared to each other, a cluster sample is not quite as awesome as a stratified sample, but easier. So here, this is the best statistical sample, but the cost is it's a little more time consuming to gather it. Here, you get an easier, quicker sample, but the cost is it might not be as awesome as your stratified sample. So, bringing all of that together now, we are going to get into the check for understandings for this lesson. So for this first one where it says identify what method was used, I tried to highlight which portion of the sentence indicated to me the sample that I was dealing with, or the method, sorry, not the sample, the sampling method I was dealing with. So A was systematic, B was a cluster because they chose all students from the math classes. C is a stratified. I have 2 groups. The first strata is male, the second strata is female, and I took the same amount from each group. So stratified. D is a cluster because they surveyed all passengers. E, voluntary response. That one probably surprised you because they added in the bad sampling methods. F is stratified, but they did something that's maybe not so awesome. They have 2 groups, so one of the groups is under 35, the other group is over 35, but they didn't take the same amount from each group. That's not a great idea. It's still stratified, but maybe not the best best stratified. G, convenience. And H is an SRS. Essentially, this is HAT method. Okay, 2, you want to estimate the proportion of high school teachers employed by Granite School District that fill, that word fill should not be there, that support having distance learning Fridays next year. So when I first did this, I, for some reason, completely missed the portion where they say, we're focusing only on high school teachers. We're focusing on high school teachers. So you can see here when I filled out the population for this problem, I have all teachers employed by Granite School District, and I really should change that to all high school teachers employed by Granite School District. Or I'll just fit it in here. And I'll write it in red as a reminder to myself that I made this mistake. So the first time I tried this problem, my strata and my clusters weren't correct because I was assuming it was all teachers of Granite School District and not just high school teachers. When we're determining our strata, we want to try to think of groups that are different from each other, but the same within the group. So we have to keep in mind that the idea behind a strata is that one strata on its own does not look like the population. So how could I break up a group or the group of all high school teachers into groups that look the same amongst but different from each other? So I was thinking that I could strata by content area. So math would be a strata, science would be a strata, English would be a strata, CTE, so on and so forth. Because I think that these teachers would have different opinions about continuing distance learning. So for instance, if I'm a PE teacher, I probably am not a huge fan of distance learning Fridays because most of what they do needs to be done in class. If I'm an English teacher, maybe I don't feel strongly against distance learning because you could have your students read on that Friday instead of doing things that must be done in class. If I'm a math teacher, I'm against distance learning Fridays, so it's easier if you guys are in class to learn with me. So I have broken them up into groups that are similar within, so all the math teachers, all the science teachers, all the English teachers, so on. But when you compare them to each other, they're different. A math teacher is going to probably have a different opinion than a PE teacher. Lastly, if I look only at the math teachers, that does not reflect the population. In order for these to look like the population, you have to take from each and group together. So my my strata would be each content area, and my stratified sample, how I would collect that is that I would use an SRS to select 25 teachers from each content area, then combine to make a sample that looks like or represents the population. How did I come up with 25? I just chose what I thought was a good number. So if I combine all of the math teachers in our entire district, that's probably over 100 math teachers. I would take 25 of those math teachers. I would take all of the science teachers, so combine all of the science teachers from every school. I would randomly take 25 of those, and how I would take them is an SRS. So I would select them from using HAT method, using technology, or using random digits. Then notice I have capitalized, I will combine them at the end. Now, with a cluster, you have to have every group that you could think of in the population in your cluster. So remember, the idea of a cluster is that if you sample everybody in the cluster, it looks like the population. So notice here, I have written, you could not cluster by content area. because like I said, if you only take the math teachers, that does not represent the population, so that is not a good cluster. But what if I clustered by high school? Well, if I clustered by high school, each high school has all of these teachers. They have math teachers, science teachers, English teachers, so on. So each high school would be my cluster. I would use an SRS to select 3 clusters or 3 high schools, and then I would survey all of the teachers in those high schools. So HAT method, I think, would be the best way to do this. We would write Kearns, Olympus, Skyline, Cypress, Granger, all of the high schools on identical slips of paper, shake, 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 draw 3 out. Those are your clusters. Survey everybody at those schools, or every teacher at those schools. Then lastly, I have another strata that I could think of, because this isn't the only strata. There could be many different strata that you guys could think of that just have not occurred to me. So one other one that I thought was you could stratify by each school's proportion of students who qualify for free and reduced lunch. So for instance, on the east side at Skyline or Olympus, they probably have very few students on free and reduced lunch because their community income is much higher than our community income. So they may have different supports for their kids when it comes to distance learning. Like they may all have reliable internet access. They may all have devices that work and consistently work. They may have the means to have their kids go to school on Fridays and get extra help if they need to. So I would imagine that more affluent schools may have a different opinion than schools where most of the kids are on free and reduced lunch. Those kids depend on having to come to the school to get their breakfast and lunch every day. They may not have reliable internet access. They may not have the access to consistently working technology, and they may not have the means to take advantage of distance learning Fridays and come in and get the extra help that they need. So that's another strata that I think that you could use to make groups that are different within the population but the same amongst each other. So these are not the only 2, but I think they're 2 really good ones. There may be other clusters that I didn't think of. If you're concerned and you're not sure if your cluster is right, just ask me or email me and I will let you know. Number 3, we're inspecting iPhones. So I'm going to briefly hit each of these, but you can pause and take what you need from my responses. Why would it be difficult to inspect an SRS of 20? Well, it's already going to take 200 minutes to inspect these phones, but then we would have to locate these phones. And if we're doing this at the very end of production, it may take a lot of time to have to go back and locate those 20 phones. So you would add that already to the 200 minutes it's going to take to inspect. And this could become a very timely endeavor that could be done in a quicker way. So SRS, it may be difficult to round up those 20 phones, and then it would add more time. B, should we inspect the last 20 phones? No. This is not a good idea because this is a convenience sample. And what is the issue with the convenience sample? These last 20 iPhones probably don't represent the population. Even though a machine is producing these iPhones, machines are fallible. As you use them more and more, their specifications may become loosened or worn out. And if you have a margin of error for putting together some part that's very small, as the day wears on, it could be that that machine starts producing parts that have a bigger margin of error. So even though it's a machine, we cannot guarantee that it's going to work exactly the same at the beginning of the day as it does at the end of the day, because it's similar to your car. Like, you need to maintain your car for it to run correctly, and the more you drive your car, the more susceptible it is to needing repairs. C, explain why a systematic sample is not a simple random sample. Well, there's two reasons. One, each phone does not have an equal chance of being chosen. And two, then that means each sample of 50 does not have an equal chance of being chosen. For it to be an SRS, if there's 100 people in your population, each person needs to have a chance of 1 out of 100 of being selected. If you don't have that, you can't call it an SRS. Then we have the tree problem. Why wouldn't it be practical for scientists to obtain an SRS? Well, in order to obtain an SRS, you would need to be able to identify and label every single tree in that area. And even though it may be a smaller portion of the Rocky Mountain National Park, that park is huge. So even a relatively small portion is still probably a lot of land to have to go and identify every single tree so that they can be labeled. What's a possible alternative is to use every tree along the park's main road. So this would be a cluster. Why would this cluster be biased? Well, I doubt that this cluster represents the population as it should. One, it's a convenience sample. So these trees likely do not represent the population. So it's a cluster sample, but we're using that cluster because it's convenient. These trees may be in worse condition because they are so near the main road. And maybe if they're in worse condition, they're more susceptible to the pine beetles. So to have a true cluster, you would need to have trees that represent the population. You wouldn't want just trees by the main road. Then lastly, the scientists get an estimate of 35% of these pine trees are infested with pine beetle. Can they conclude that exactly 35% of all the pine trees are infested? Well, no. These scientists have found an estimate for the proportion of all pine trees in the area that have been infested. They can be confident that P is approximately 0.35, but not exactly 0.35 because of sampling variability. We know that if we took another sample, we would likely get an estimate that is different. So for this sample, we got 35%, but it's completely reasonable that we would take another sample and get 34%, and another sample and get 36%, because that's how sampling works. Often, our samples will produce different estimates, which is why we say it's approximately 35%. So, because of sampling variability, our sample values will be different. We can only be confident that it's around 35%, not exactly 35%. This is one of the most important problems in this check for understanding. So make sure that you feel pretty good about that. Now we get into actually having to describe our cluster or stratified sample. So then these last two problems are the other most important problems. We have a stadium, and we're talking about concessions sold at this stadium. So the athletic department is considering a stratified sample. What would you recommend as strata and why? So I would recommend by stratifying by the type of seat or the color according to the map. Why? Because people who can afford more expensive seats probably have different opinions about the concessions than people who can afford cheaper seats. So I would imagine that if you have the more expensive seats, you probably have more money to spend on concessions. If you have the cheaper seats, maybe you don't want to pay $10 for a hot dog, so you're going to spend less money on concessions. Notice here that it just says, what would you recommend as strata and why? Whereas the next problem, well, actually it doesn't. So all I had to do on this problem was say what and why. A cluster sample might be easier to obtain. We'll actually explain why and what would you recommend as clusters. Well, if we do a stratified random sample, it will include seats from all over the stadium. So we might choose 2 from each color. We could have gotten 42, 20, 6, 28, 33, and 9, and you would have to be going all over the stadium. That could make it very time-consuming to obtain. A cluster sample would be easier to obtain because the people selected would be sitting near each other. I would split the stadium into quarters and use each quarter as a cluster, and I marked that on the picture above. Each cluster now contains all 3 types of seating, which does represent the population. One thing to note before I move on is that I knew that they would be sitting near each other because that's what my notes say a cluster sample is. A cluster sample is chosen based off of individuals that are located near each other. So if I go up here and I look, each one of these quadrants or clusters includes the same amount of seats and includes all 3 types of seats. So same amount of people in the green seating, same amount of people in the orange, same amount in the blue, and notice all 3 colors are in there. Our last problem is similar, but in this one, I wanted to give you some idea about how you would choose that sample. So if you're missing anything that I have, particularly on this problem, I would make sure that you add it in either on a post-it note or erase and add it in, because the likelihood you'll be asked to do something like this on a test is very high. So you have a hotel with 30 floors, 40 rooms on each floor, so that means you have a total of 1,200 rooms. Further, this hotel has 2 types of room. You have rooms facing the golf course and rooms facing the water. I think both are probably decent views, but they charge extra for the water, which would indicate that maybe that's the more desired view. The hotel wants to survey 120 guests during their stay about their overall satisfaction. Now, when they say 120 guests, I think what they really mean is 120 rooms. So we're going to refer to our survey as rooms and not guests. So first one, explain why choosing a stratified sample might be preferable to an SRS, and what would you use as strata. This goes back to the auditorium problem. If you take a regular SRS, you could end up with a majority of rooms that are on the water side, or a majority of rooms that are on the golf side. And we think that the satisfaction might be different between those 2 groups. Like, what if somebody is more satisfied because they got a really good view during their stay, whereas the people on the golf side, less satisfied, not as awesome as a view. The other thing to consider is what floor your room is on. Like, maybe people on the highest floors are more satisfied because their view is even better. Maybe people on the lower floors, less satisfied. Maybe it's really noisy on the lower floors because you got all those people above you. Maybe the view's just not as awesome. It could also be different based off of floor. So we have 2 different situations here. We could have that their satisfaction is affected by their view, but also that their satisfaction could be affected by what floor they're on. Because of that, you don't want to take an SRS, because what if you get the majority of one type of room? So a stratified random sample might be preferable to an SRS because stratifying ensures that each type of room and even each floor are equally represented in the sample. Using an SRS could result in a sample that has a majority of rooms that face the golf course or a majority of rooms on the lower floors. Using an SRS could lead to a sample that does not accurately reflect the population. So that's the issue with an SRS. Then next, what would I use as my strata? Well, I've already kind of discussed that I would stratify by floor and view. So I would use floor and view as my strata. Now I'm going to go further and briefly describe how I would do that. So I would call the first strata 1W. That stands for first floor water view. 1G is first floor golf view. Then I would have 2W, 2G, 3W, 3G, 4W, 4G, all the way up to 30W, 30G, because there are 30 floors. That means that there's 2 strata per floor. There's a water view and a golf view. So there would be 60 strata total. 2 per floor, 30 floors, so 60 strata. I would then use an SRS to select 2 rooms from each strata, because 2 times 60 gives me the 120 that I want to survey. It is extremely important that you can describe what I have at the bottom and on this post-it note. That you know what your strata are, that you know how many strata you have, and that you know how many people you would take from each strata if they give you a sample size. If you have any questions on this, make sure that you get it cleared up when you see me or you send me an email. So even though the problem doesn't say this, it is very important that you understand how to get the sample that you're talking about. The last problem says, why might a cluster sample be a simpler option? Well, because in a cluster sample, you could just use each floor as a cluster. It takes care of making sure that you have the water view and the golf view in your sample. So to obtain a cluster sample of 120, you would only need to go to 3 floors instead of every floor, as would be needed to obtain the stratified sample in Part A. So Part A, you got to go to every floor and choose 2 people from each side, or 2 rooms from each side. A cluster, you would only need to go to 3 floors. How do I know that? How do I know that I only need to go to 3 floors? Make sure that you know that. So down here, I just have the bullet points that are important to the understanding behind this. Number 1, using floors as clusters works because each floor has both views. And 2, if there are 40 rooms per floor, we would use an SRS to select 3 floors and survey all rooms on those floors. So if I need 120 rooms in my sample, and there are 40 per floor, that means that I need 3 floors in my sample. I'm going to just make sure that I say one more time, especially on the part where you select. If you're not understanding how I know that my sample here would produce 60 strata, and that I need to select 2 rooms from each strata, you got to ask me and get that cleared up. And then here, if you're confused about how I know that I would take 3 floors as my sample so that I could have 120 rooms in my sample, make sure that you ask me. Okay, thank you for hanging in. I know that these solutions are longer, but like I've said before, because we know these will be on our AP test, 100%, no doubt in my mind, a question like this will be on your actual AP exam. We must make sure that we understand it and can describe it. Okay, love you guys.